Hello everyone, very good afternoon to all. Now, as we are studying the preparation method for alcohols, aldehyde and ketones. Okay. Now we will continue the preparation method for aldehydes and ketones. In the last class, I have told you the preparation via dehydrogenation of alcohol, where I have mentioned that from only primary and secondary alcohols we get what? Aldehyde and ketone, and from tertiary alcohol we will not get any aldehyde or ketone because there is no hydrogen will be there. Okay. Now we'll be discussing preparation method for aldehydes via oxidation process. What? Preparation via oxidation. Preparation via oxidation method. Oxidation is a very important preparation or reaction of the organic chemistry. Okay, preparation for various types of compound can be done by oxidation method. Okay, before I start this preparation, I like to mention here something. Okay, which will be very helpful to other reactions also in further cases. Okay. If you oxidize alcohol, then we'll get what? Or secondary alcohol. Oxidation will get carboxylic acid. Oxidation will get carboxylic acid. Okay, this sequence is very important. Okay, this sequence is very important for preparation method. By oxidation, what we means? By oxidation, what we means? By oxidation, we means addition of oxygen or removal of hydrogen. Okay, in terms of atoms. In terms of atoms addition. Okay, atoms addition. We are adding oxygen or replacing hydrogen. In terms of atom, we are explaining this. But in case of redoxidation, you have studied the electron transfer process. Okay, oxidation and reduction is termed there also, but it was treated as differently as if electron is added, then there will be reduction. If electron is removed, or if a metal gives up electron to other element, then metal will be oxidized. This is called oxidation. Different cases. Okay. Now you should remember this sequence, and reverse of this oxidation will be what? Reverse of oxidation will be reduction. That means if we reduction this carboxylic acid, then we will get this aldehyde. From this aldehyde we will get this what? This alcohol. Okay. So keep in mind this simple trick. Okay, simple tricks. If you cannot remember anything while preparation method, just remember the simple method. Okay, simple method. Actually, oxidation of alcohol doesn't stop here quite frequently. It is very difficult to stop at this place. Okay, it's very difficult. While in lab or in other medical means other pharmaceutical cases, while we are oxidizing this alcohol to aldehyde product. Okay, aldehyde product. It will not stop here only. Okay, it will not stop here. It will be further oxidized to carboxylic acid. It is very important to use specific reagent so that it got stuck in the aldehyde and we get the appropriate aldehyde. Okay, which will not further oxidize to carboxylic acid. Okay. Now we will start oxidation method. First of all, we will start it by using chromium 6 oxidation state, where we are using the reagent sodium dichromate or potassium dichromate in sulfonic acid. Sulfonic acid such as this sulfuric acid. Okay, sulfuric acid. Again, I am telling you that in this case, in this particular reagent, it is important here. We should notice the oxidation state of this metal. This element, chromium. This chromium is oxidation. It is very important oxidizing agent. Okay, it is very important oxidizing agent where chromium is in its 6th state. Okay, where chromium is in its 6th state, and it will be further when it get involved in the reaction. It will be not in its own 6th oxidation state. It will be reduced. It will be reduced to, I think, oxidation state to 2. I think chromium 6 to chromium 6 to chromium 2. Okay, as we know, chromium lies in the transition element. Okay, transition element. So there may be various oxidation states. Actually, I am not sure which one will we get after the completion of the reaction. Okay, please look into this. Okay, now we are dealing with the oxidation process. First of all, we are using chromium 6. In this case, as we know, the alcohol, when treated with say, this is called potassium dichromate. This is called potassium dichromate in sulfuric acid, and process is called oxidation process, and we get what? We get aldehyde. We get aldehyde for primary alcohol. This is primary alcohol. For secondary alcohol, say this. This is cyclohexanol. Cyclohexanol, same condition, will be oxidizes into this. This is what? This is cyclohexanol. This is cyclohexanol. This is a ketone. Why this is a ketone? Because this is a secondary alcohol. This is a secondary alcohol. Okay? Don't be confused. Primary, secondary, you must know how to evaluate this primary, secondary. It's very easy. Okay? There are many reagents. Okay, there are many reagents in the organic literature, organic chemistry literature, which are imposed to get aldehyde and ketones from primary alcohols. Okay, there are many certain reagents specifically for primary alcohol and secondary alcohol, on which oxidation is done and will get aldehyde and ketone. Now let's look into another oxidation reagent. Okay, scarlet reagent. Okay, scarlet reagent and Collins reagent. Okay, scarlet reagent. Here, chromium trioxide is used in pyridine. Okay, chromium trioxide is used in pyridine as solvent. Okay, pyridine as solvent. But in this case, Collins reagent is quite a modification of this scarlet reagent. Okay, Collins reagent is quite a little bit difference, little modification from skin. Here, chromium trioxide is get addition to the class pyridine. In what is this? This is called DCM. DCM as a solvent. DCM as a solvent. The full name of DCM is dichloromethane. Okay, dichloromethane. But you have to know the IUPAC name also. Okay, please go through it. DCM is dichloromethane. Here, as you see, chromium trioxide here using reagent alone in presence of pyridine as solvent. Okay, in presence of pyridine. But in Collins reagent, this will be combined with this, but the solvent is different. Okay, solvent is different. In the intermediate step here, they will form a complex like this. Pyridine, you know, pyridine is like this. Plus okay, this type of intermediate complex will be formed in this Collins reagent while oxidation. Okay, now as I have already mentioned you that only primary and secondary alcohol will be converted into what? Aldehyde and ketone. Okay, examples are this specific example I am going to give you. So, can you tell me whether this is a steric reagent or Collins reagent? This is a Collins reagent. We have to identify this on the basis of solvent, whatever is given here. Okay, whatever is given here, we have to identify this. Here, DCN as a solvent, so it will be act as Collins reagent. Collins, okay, Collins reagent. Now, you see, there are two types of alcohol in this compound. Which one will be oxidizes to aldehyde? Okay? Which one? It will be this one, because this is secondary, this is tertiary. This is tertiary. This carbon attached to this OS has been attached to three types of other carbon atoms. Okay, that's why this is tertiary alcohol, and this is secondary alcohol. So this secondary alcohol, no need to worry about other things, other substituents. Just look at the alcohol, go there, and just what you should do, you should convert it into this oxygen by replacing H, and keep remember the valency here. Oxidation I have having valency 2. Oxidation having valency 2. Here hydrogen is being replaced, so we should add another bond. We should add another bond to maintain the valency. Okay. Okay. This. See, I forget to give the name of the compound. Okay. Another specific, I am giving you the specific some example. Okay, specific example. This is epoxy alcohol. This is epoxy alcohol. This is epoxy alcohol. In pyridine. Okay, in pyridine. In pyridine. So get back there means we have to look the reagent name which will be suitable for this reagent. This, it will be what? It will be the scarlet. Why scarlet? Because chromium trioxide has been used in pyridine as solvent. So what will you get? Will be this. This oxygen, this alcohol will be converted into what? This alcohol will be converted into this. Okay, this alcohol. That alcohol has been converted into this. Okay, this is the primary alcohol. Okay, don't forget this. This is the primary alcohol. Primary alcohol will be converted into aldehyde, and secondary alcohol will be converted into ketone. Another important example will get another important reagent for oxidation of alcohol. This will be PCC, pyridinium chloro. Okay, pyridinium chloro. Here you see, in this reagent, it is a mixture of three. Reagent. Okay, pyridinium chlorine is a mixture of three component in ratio of 1:1. It is an equivalent ratio. Okay, it is a mixture of chromium trioxide, HCl, and pyridine. Okay, chromium trioxide, HCl, and pyridine. Okay, it will be look like, the intermediate will be look like as C6H5 and HCl. Okay, this will be this. The intermediate will be look like this. Okay, it is a very important reagent. Why it is an important reagent? It is a very specific what it does to convert it. What it does is, it is very specific because it will convert only alcohols into aldehyde. It will not affect or not oxidizes other type of functional group or like say double bond here. Oxidation of PCC is very specific, so it will oxidizes this into only this. Okay, it will not oxidizes this double bond to this. It will be not happen for PCC if we use PCC. Okay, PCC is very specific. That's why among all the reagent we have studied in the class using chromium as reagent. Among all of this, PCC is most widely used. Okay, PCC we have studied. Now PBC is another family member of PCC. Okay, from PCC another we get family member of PCC is PDC, pyridinium dichromate. Pyridinium dichromate. here one specific sense, one notice. So what I am saying is another noticeable change is here in place of HCl. Okay, in place of HCl, what is this? This is pyridine. This is pyridine. In here PDC, in place of HCl there will be H2O. H2O means water molecule. Okay, water. Okay. In this PCC reagent we will not use any water. Actually, this type of reagent, this type of oxidation reagent are very dry reaction. Okay, very dry reaction means it does not involve any presence of water or air. Okay, this is very important condition. So in 1:1:2 ratio will be same, but one noticeable change is there. In place of HCl there will be H2O. As usual, it will be converted. It will be converted only for primary and secondary alcohols to aldehyde and ketone. Okay, it will be oxidized only primary and secondary alcohol. Another important reagent is Jones oxidation. Jones reagent is use chromium trioxide plus H2SO4 sulfuric acid in acetone as solvent. Okay, in acetone as solvent. In most of the cases you will find that acetone is used. Acetone is being used because acetone is a very inert. So it can be used very widely as solvent. Okay, very widely as solvent. This reaction needs very low temperature. Actually, quite very low, 0 degree centigrade. 0 degree centigrade. Okay, 0 degree centigrade. 0 degree centigrade means in terms of Kelvin scale. How many? What amount will be? 273 Kelvin. Okay, 273 Kelvin scale has been widely used. While we are doing the mathematical problem for physical solution, we have to convert this centrigate into Kelvin. Okay, this centrigate into Kelvin. So Jones reagent is widely used because one of the widely used solvent, because it is primarily used for primary alcohol and special used for this allylic alcohol. Sorry. This allylic alcohol. Okay, this allylic alcohol will oxidize into this allylic alcohol. Why this is allylic alcohol? When the carbon is, if you see, this carbon is not directly attached to this double bond. Okay, this carbon is not directly attached to this carbon. It will be one carbon atom away from the double bond. That's why it is called allylic. This allylic alcohol and benzylic alcohol. Okay, benzylic alcohol will be benzaldehyde. Okay, benzaldehyde. This will be changed. Yes, I have given you the conversion. Only this will be changes into this alcohol will be changes into aldehyde. Okay, this is very useful. Jones reagent is very useful for conversion of allylic and benzylic alcohol to aldehyde and ketones. Okay, allylic and benzylic, especially for allylic and benzylic. What is allylic and benzylic? Benzylic is this portion is benzylic, and allylic, what allylic is? I have already told you that this, when carbon is not directly attached to double bonded carbon, just one carbon atom away from the double bonded carbon, then this will be the allyl. Okay, then this will be the allyl.
Okay.
Another one of the important named oxidation method. Okay, named oxidation method. Whatever we have studied is the reagent, named reagent. Okay, named reagent. Now this is a named oxidation method for preparation of alcohol. What is this? This is an opener oxidation. This is an opener oxidation. Opener oxidation method. What type of reagent is used here? It's only secondary alcohol. We have to look into this secondary alcohol, and here in excess মানে বেসিকে কি দিয়া হয় এসিটোন দিয়া হয় এসিটোন দিলে কি হবে it is a secondary alcohol in presence of acetone কি হবো এই যোনটো বস্তু ইয়াত যোনটো আছে এইটো কি হৈ যাব তোমাৰ কিটোনলৈ কনভার্ট হৈ যাব কিটোন আৰু এই যে এক্সেস এসিটোনৰ যোনটো আছে এক্সেস এসিটোনৰ এটো কি হৈ যাব এটো ৰিডিউস হৈ যাব এক্সেস এসিটোন যে আছিল তাৰ এটো কি হৈ যাব ৰিডিউস হৈ কি হ'ব আইসোপ্রোপাইল এলকোহল হ'ব এটো কি হয় আইসো গ্রুপ আইসোপ্রোপাইল এলকোহল এটো গ্রুপ কি হৈছে আইসোপ্রোপাইল চোৱা কার্বন দুটা একে গ্রুপ হৈ থাকিলে এটো কি হয় আইসোপ্রোপাইল কেলে হৈছে তিনটা কার্বন আছে আৰু এটো কি হ'ব হাইড্রোজেনৰ লগত OH আইসোপ্রোপাইল এলকোহল ওপেনার অক্সিডেশন এটো এটা ইম্পর্টেন্ট মেথড হয় দে প্ৰিপাৰেচনৰ কাৰণে ইয়াত আমি কি চাব লাগিব ইয়াত সেকেন্ডাৰী হ'ল অনলি ফৰ সেকেন্ডাৰী আৰু এটো বহুত স্পেসিফিক এটা ৰিঅ্যাকশন হয় এটো বহুত স্পেসিফিক ৰিঅ্যাকশন কাৰণ ইয়াত যেনিটা থাকিব এটো এই সেকেন্ডাৰী এলকোহলটো সদায় কনভার্ট হ'ব ইয়াত আৰু বেলেগ যদি ডাবল বন্ডেড যদি থাকে থাকিলেও আমি যখনি পাইছিলো এই ডাবল বন্ড থাকিলেও ই অক্সিডাইজ নহয় কিন্তু বুজি পাইছা না ই অক্সিডাইজ নহয় অনলি এইটোহে অক্সিডাইজ তোমাৰ এলকোহল আৰু এটো ৰিডিউস হয় এটা আইসোপ্রোপাইল এলকোহল এইটো আইসোপ্রোপাইল এলকোহল আৰু এটো কিটোনলৈ হৈ যাব ঠিক আছে।